Chapter 8 Confidence Interval. Homework problem number 4. A pharmaceutical company makes a drug. It is assumed that the distribution of the length of time they last, so the drug lasts, is approximately normal. Researchers in a hospital used the drug on a random sample of 9 patients. So a sample of 9 patients tell us sample size n equals 9. Okay, and denote the sample size. The effective periods of the drug for these patients result in a sample mean of 2.53 hours. So sample mean is given to us, and we need to know the symbol for sample mean is x bar. Okay, that is 2.53. And a sample standard deviation, okay, and that is given to us. So you have to label each number correspondingly using the symbols, because those are the values that we need for the formula. So these are all the things that are given to us. The question is asking for, so what do we need to know is a 95% confidence interval for the population mean length of effective time. Okay, so we have a sample of 9 people, and we know that the distribution is approximately normal. So that means we can use the formula that are given to you in the formula sheet in the handout of week 7. Okay, you need to download it and print it out, or just write it down. So these are the things that are given to us. How do we find a 95% confidence interval? So we need to look at the table. Okay, under the confidence interval table, right, that box, what do we know? What are the conditions? Do we know sigma? Take a look. We know n, we know x bar, we know s. We have sigma is unknown. Unlike the previous problem, sigma is given to us. Okay, we do not have the population standard deviation. So what it's telling us is use this confidence interval formula. Okay, so the formula that we need is x bar plus, okay, so x bar plus or minus, so that means you need to do 2 calculations. T times s divided by square root of n. Now I just want to point out, earlier we used a different formula, right? If sigma known, we use a different formula, but it's very similar. It's x bar plus or minus the z-score times, instead of s is sigma, right, over square root of n. So this is the difference between whether sigma is known or whether sigma is unknown. If we know sigma, we need to use a z table. If we do not know sigma, we need to use the t table. And then you need to learn how to use a new table, okay, how to find the t-score. And I'm going to tell you the main idea. You do need to find degree of freedom. So that's one extra parameter that we need to know. And degree of freedom is defined to be n minus 1. So you have to write everything down on the side to keep track of what you need to find. So now we recap, okay, what do we know? And then we can apply the formula. We know the sample size n is 9. We know the sample mean x bar is 2.53. and the population standard deviation sigma is unknown. So, but we do know the sample standard deviation S is 0.35. So we will need to use the t-table, okay? And how to find a 95% confidence interval? We apply this formula and we plug in. So what is x bar? 2.53. Plus or minus, right? You can do subtract first. You can do add first, it's fine. Okay, you need both anyways. So x bar. Now how to find this t value? So you will have to look at the t-table. And how do you use it? Oh, little t. So you have to look at the right under the t-table, okay? You have cumulative probability 1 tail, 2 tail, and right after that, you have df. That means df right here, degree of freedom. Degree of freedom df equals the sample, which is 9 sample size, subtract 1. So degree of freedom is 8. So you need to look at row 8. Okay, so go all the way to find a number. But how do you find 95%, right? So you have to look at bottom. And you need to find 95%. Okay, locate that column. And you look up. And the number that it corresponds to should be 2.306. Okay, so, but again, if you have a TI 84, the textbook tell you how to use it. But if you're using the tradition way, and you're using TI 34, it doesn't have those functions, so you just have to look up the table. Okay, so it's 2.306. So this t is 2.306. Okay, you multiply by s, which is 0.35. And then you divide it by square root of n. And n is the sample size, which is 9. So you enter all this into your calculator. Okay, 2.53 subtract 2.306 times 0.35 divided by square root of 9. Okay, and if some of you might know square root of 9 is just 3. You can enter that too. So when you enter this into the calculator, you should get, okay, you should get a number, 2.260, and you're supposed to round it to 2 decimal. So it should be 2.26, because right after 6 is 0. Okay, so you get rid of it. Now the next one is 2.53, okay, plus 2.306 times 0.35 divided by square root of 9. Now you use a calculator. You pretty much enter the same thing except you do a plus sign. You get 2.79, and right after the 9 you get another 9, okay, and then 0.33, so on. How do you round it? Okay, you round to 2 decimal. Look at the third decimal is a 9. If I tell you I sell you something for 2.79 cents, right, or 2.799, okay, that's money, right? Do you know how much you're supposed to pay if this is money? You would know, okay, it's more than $2.79. Then you have to pay $2.80, right? So that's how to make sense. So it's roughly 2.80. So maybe use money to kind of make sense out of the rounding, okay? Because it's a 9, you had to add 1 to the 9. And then you change the 9 to 10, right? What does it mean? Well, look a little bit further. You have to add 1 to 79. 1 plus 79 is 80, right? So it's 2.80. So you answer the question, right? The 95% confidence interval is from, so the effective time is 2.26 hour to 2.80 hours. Okay, so that is the confidence interval.